5 times 5 is?
25.
Yeah. Hey folks, welcome out there. It's a Mathline day. You got it. You found me. I'm Ernie Roberts. I'm your host for this afternoon session. Now, some of you are saying, well, wait a minute, this is kind of a weekday. What's going on? Yeah, maybe this is a weekday, maybe it's a weekend. You never know when you're accessing this. But you know what? We are doing a specialized segment today just for you guys. A little bit of test prep in some of our topics as we head into the summer season. So don't get alarmed. Sit back, get those pencils, get those papers. Grab a calculator even, and let's do some math together. How about it? Let's see what we're going to talk about today, guys. What we got? A ratio and proportion review. How much better can it get? All right, it is Mathline test prep here. So take some notes, watch some problems here, and we're going to do a little, some organic algebra, so to speak, I like to call it. But we're going to look at ratios, proportions, and how they connect, and applications even. All right, let's take a review time. All right, first problem. Starting off, we're talking ratios. Now, ratios, by the way, are just simply a way to compare two numbers. Now, I'm going to put a little note over here because we may see the ratio written in this form, like A to B. We always like to have those as integer values, integral values if we can get there. Both of those would be integers. Or, yes, I digress, we could write it as a fraction. Hint the word ratio, rational numbers. That's where we go, all right? So take a look. There we go. There we go. I'll write them both for you, okay? Just for that, if we look at some of these answers, all right? Obviously, when we make proportions, this is a much nicer form to use. Many times when we talk about ratio, we see the colon and work from there. So don't let that bother you. That just means A parts to B parts, that kind of thing, all right? So let's take a look at our first problem here, which says approximately 3 of 30 people are left-handed. All right, that's giving me an idea. Actually, it's giving me a ratio. It says 3 out of 30. But, oh, there's always a but in there. What is the ratio of left-handed to right-handed people? Now, let's think about this. This said people, didn't it? You got to read a little between the lines. We don't like to do that a lot of times, but we're going to read between the lines on this one, all right? Because that means if 3 of those 30 people are left-handed, what does that leave for the right-handed? You all got that? Oh, my, yes. We want to say 30 minus 3. So let's think about it. 30, lose 3 of them. That means we have, in this case, let's talk about it here. We've got 3 left-handed. And now we have what? 27 right-handed. My friends, that's going to change the ratio, at least the question we're asking, all right? Now let's notice what else it says. What is the ratio of left-handed people to right-handed? So in other words, our A is going to be our left-handed folks, our B is going to be our right-handed folks, all right? So let's see how that's going to stack up. We're going to see with the colon first. And somebody said, was that okay, Arnett? Those are big numbers. I agree. Let's reduce them because we can divide 3 into both of those. And let me point out to you, remember I said we want to compare two integers? So even, for example, 3 divides into 27 beautifully, and it makes 9. We still need to keep the 1 in front of this 9, all right? Because we're talking a fraction. In this case, it's like saying, look at it as a fraction, absolutely. Say 3 over 27, that would bring us down to what? 1/9. 1 divided by 9. Remember these little fraction symbols, this division, basically, and that's basically just from reducing the fraction that we get there. Again, why did we do 27? Because this was basically all people. The ratio of left-handed to right-handed. Well, there you go, back to 3 and 27. So take it there, write the ratio, reduce it. When you can reduce it, go for a reduced ratio. We really like those also. And there you have it. Quick start, all right? Everybody good on that? Context. Read the context of the problem, also an important thing to do on what we're going to be looking at today. So let's take another little ratio example, another little trip down the, looks like a trail mix. We're going to go hiking maybe. Artiste is making trail mix to sell, all right? She sells the stuff, and it's good stuff to eat, right? So sometimes we use it for hiking. Sometimes we just like to eat around the house. But anyway, you've got the 3-to-2 ratio of fruits to nuts in this thing, all right? And you're going to have 7.5 pounds of the mix. How many pounds of fruit and nuts are needed when you mix all these things together, all right? So you say, well, Ernie, that's a 3-to-2 ratio. And I've got it written like this. We could also write 3/2, but right now I think 3-to-2 looks pretty good. All right, that's works for us. She's going to make 7.5 pounds of mix. Now, let's think. We're putting the fruit, we're putting the nuts together, and we're going to come up with this great thing called trail mix. Now, you can tell me, I can tell you, we all know, right? 3 + 2 does not give us 7.5. Ooh, that's a ratio. That's not the exact amount, okay? We're not taking 3 pounds and 2 pounds. We are taking 3 times something and 2 times that same something. That's what we're talking about here if we're going to get to the 7.5 or 7.5 pounds of the mix. How many pounds of each are needed, all right? So let's take a look and see where it's going. That means we are going to mix this part. By the way, you got it. Everybody knows that's the fruits, that's the nuts, all right? Put them together, we get trail mix. So let's see, I just said it, put it together, so let's do that. How about it? 3x plus 2x equals, aha, we got it. Where's 7.5 come into play? Right there. Now again, you've got 3-to-2. You're making 7.5 pounds of mix. We want to know how many pounds of fruit and nuts are needed, all right? So what we're going to have to figure out is not just x, but we're going to have to come back and say, oh, what's 3 times x? What's 2 times x when we get the final answer? Now, the answer is going to be pretty easy to come up with. The x part is, again, we got to apply it back to the context of our problem. So 3x, 2x, ding-a-ding-a-ding, oh, 5x, right? That was easy. Just add the like terms, right? Now, keep in mind, we're talking pounds here. So it looks like our x value is going to equal 1.5, what is it? Pounds. Now, again, caution, that's not how much fruit we have. That's not how many nuts we have. That's how we multiply by. So we're going to take out here, we're going to take this 3x, and we're going to take this 2x, and we're going to do just that. We're going to substitute 1.5. We're going to say 3 times 1.5. Over here, we're going to say 2 times 1.5. And my friends, we're hoping what? That adds up to 7.5, and we have this wonderful, great artiste-made trail mix. What can I say? It'd be wonderful. So here we go. 4.5 is what we're going to get because that's what happens. We multiply 1.5 times 3. We get that many pounds. So that's your what? That's your fruits, right? And those are pounds. Let's make sure that looks like it. So that's our fruits. Over here, we're going to have 3, or for those of you who like the decimal, there you go. We'll put a 0 after the decimal point. And again, pounds of, this time, the nuts. Total amount, 7.5 pounds, okay? And there you have your check. So what's the answer to the question, by the way? How many pounds of each? There we have them. There we are. Ratio. So when you see these things, understand you're going to be doing what? You're going to need to multiply both of those pretty much by the same value of some sort. So we call it x because we don't know exactly what it's going to be until we solve out our little equation. All right? You got it, folks? You see it? Get with it? Absolutely. That's a great type. ACT, SAT, geometry, algebra. Oh my goodness, I can just go all the way different types of course testing that you could see that on. Okay, not to mention the PSAT. Don't want to leave them out either. All right. So some of you people out there in GRE land may be seeing something like that if you're taking the graduate record exam and other little exams to get you further along in life. Okay, speaking of getting further along with life, let's look at our next problem. How's that? If 3x plus 6 equals 2y plus 6, ooh, what's the x to y ratio? Notice I even spelled it out so you understood. That's what we want to know. X to y, what's the ratio here? Got to be 2 integers, right? Everybody nod your head out there? Great. Everybody nod your head. Why do we have a 6? Oh, we'll figure that out, all right? So let's go ahead and write the problem down at home. 3x plus your 6 equals 2y. No, I did not misprint that. That's a y plus 6. Now, what we want to do in the end is end up with a fraction of sorts. Yes, a fraction of sorts. How's that? We want to get x over y. We're going to play the fraction part, although it says for an x-y ratio. We'll come back to that. Everybody got that? We'll come back to that. But we want to write using fraction form here in just a second. First of all, Anytime you've got a problem like this where you're trying to get an x to y ratio, these are distractors. You don't want them, you don't need them. They are certainly not going to help you if they don't disappear. And in this case, let's make one disappear. We'll subtract 6 off the left. We're going to also subtract 6 off the right. And that's going to leave me with 3x and 2y. So again, you're just adding 6 to both sides so you can remove them. They're very nice. We subtract them off, and there we have it. 3x equaling 2y. Now, here's where we got to think a little bit. It's almost like we're going to make a little proportion out of this. Remember we talked about this ratio and proportion review? So let's see what happens if we could get down to x over y. Some of you say, well, that would be interesting, wouldn't it? Yes, it would be. So let's see what happens with x over y. And my friends, what I want to do is fill in the two blanks over here. What numbers will x over y equal? Now, some of you are saying, oh, Ernie, I know the answer. It's 3 to 2. It's 3 over 2. Well, let's see what happens if we put 3 over 2 in here. What would happen? Cross multiply. That's what we do, right, when we try to get a proportion to unwind itself. And what do we have? We do not have 3x equals 2y. Everybody say that with me. We do not have 3x equals 2y. What do we have? We've got a 2x equals 3y. Is that the same? That's absolutely not. We just changed the problem, didn't we? We do not, repeat, do not want to go that route. So let's go back, try the other way that we were thinking about. You know, most of you are saying, well, then 3 over 2, I guess it's 2 over 3, right, Ernie? Yes, it is. That's what it is. Let's see why it works. All right, we'll put in the 2y. Let's put our x over y. And we're going to go with 2 over 3. Look what happens when you cross multiply. There we go. It does check back, doesn't it? So this is the ratio we're wanting. Now, to get it into this form, it's not difficult, folks, is it? Not difficult at all. It's basically what? 2 to 3. Remember, the fraction translates to the colon very easily. And there you have it. A ratio as 2 over 3 or 2/3. Over here, 2 to 3. Another way we're thinking it. 2 parts of whatever, what is it? 2 parts of y? No, 2 parts of x, right? Because we're going to put in that 3 times 2. And we'll have 3 y's for those two to balance them out, okay, in that case. So your ratio is 2 to 3, x to y. Got it? Everybody good? Great. Now, let's talk a little bit more. I kind of mentioned proportion there, and some of you went like, whoa, that was pretty quick, going from ratio to proportion. Remember, it is a review segment. I could do a whole show on ratio word problems, which is an idea. Maybe I'll do that this summer, okay, or maybe in the fall. But we could definitely go there and have some fun with those things and a lot of practical applications. Now, let's take a look at our next little problem with proportions here. And we're going to scramble, or we're going to work with 1, 2, 3, and 6. One time each, all right? In other words, I'm going to create a proportion, then I'm going to create another and another that are all true. You're like, whoa, wow, how does he do that? Is it guess and check? No, we're going to kind of think about it. Let's suppose I want to start with 1/2. I'm going to create proportions here. So there's the first one. So that allows me to use 1 and 2. Now I've got to figure out how to do 3 and 6 with that. Well, you know what? I'll tell you what. I need to figure out how to put the other two integers we got there, the 3 and the 6, to make this a true statement. Okay, I want to make it true. Now, so we're going to chance for false, but let's get the true b's out of the way first, all right? So we got 1/2, and we're going to have 3 over 6. You know why I thought that? Well, one thing, I've got a smaller number in the numerator here and a larger number in the denominator. So I should keep the same pattern. Otherwise, we get, as they say, out of proportion, or, you know, that's the problem. That's not what we want to have happen here, right? We want to be able to cross multiply, remember the game? And it says, how do we check? How do we create 3 and justify our choices? Here we go. Here we got it. 1 times 6 does equal, notice how I'm doing that, 2 times 3. You get 6 equals 6. Life is good, folks. There we go. All right. Now, got to mix them up a little differently. 3 different proportions here. So how about it? You want to go with, I like the idea. Let's go with 1 over 3. Ooh, 1 over 3. All right. what's going to happen on the other side? How can I make this proportion also work? Thinking about it at home? I hope you are. Again, I got to use the other, remember, I can only use these digits once. I can only use them once, and I don't want to use them more than once because that'll mess things up, unless I'm just saying 1/3 equals 1/3, which doesn't make much sense, does it? So let's play with the 2 and the 6. How are they going to go? Well, you guess again. No, don't guess again. We know, right? We've got a numerator that's smaller than the denominator, and we'll put that 2 over 6. Boom, boom, there we are. Cross, we're going to check. Yeah, we got to check. And guess what? I get 6. Well, let me write it down here, all right? I still get 1 times 6. Let me see if we can write 1 times 6. There we go. Equals 2 times 3. So 1 times 6, we'll make it look like a 6. That's closer. And we got 6 equaling to 6. My goodness, it checked out once more. We got 2 out of 3. Everybody good on it? Well, what's the next one going to be? I bet someone's out there saying, I'm going to put 1 over 6. And we'll try that in a minute. And it's not going to fly, is it? We got a problem there. Let's do one more option here. How about, you ready for this one? How about 6 over 2? Whoa. You say, Ernie, can the numerator allowed to be bigger than the denominator? Yeah, in a proportion we're allowed to. It's okay. But what are we going to do with my other 2 digits that I have not used? Now, we used the 2 and the 6 first here. So what are we going to put in here? We're going to do what? 3 over 1. All right. Again, we went the larger one, so we keep that. We got to keep it in proportion that way. In other words, our numerators both have to be larger than the denominators. Now, the ultimate checking point is we've got to be able to do what? Cross multiply. Everybody with me? Let's cross multiply. You've seen these 6s. You're probably getting sick of them, all right? Bunch of them, aren't there? But we've got this time, how about it? We got 6 times 1 equaling, looks like 2 times 3. I'm going to go with 6 equals 6 again. So in other words, all 3 of these were legitimate ways to have a proportion that works, comparing these 4 numbers. Each proportion gave us 6 equals 6. Now, remember what I said? Let's play it. Let's say we're going to do 1 over 6, all right? And some of you probably thought, well, why not? He did everything else. He did 1 over 2, 1 over 3. Why didn't you do 1 over 6, Ernie? Because, keep in mind, 1 is obviously smaller than 6, so I'm going to follow that suit. I'm going to put 2 and 3 over here, and we're going to see this thing is way out of whack, and everybody's already saying, well, Ernie, I know 1/6 doesn't equal 2/3 because you watch Mathline, right? You know that. But look what happens. The real proof and truth here, when we cross multiply, we're way lopsided. We get 1 times 3 going one way, 2 times 6 going the other. Oh my goodness, 3 equals 12? Absolutely not. So this one is our false baby, okay? And anytime you basically get out of sync here, or you try to put something together that's not going to fly, in other words, this proportion was fine as long as 1 and 6 were on the diagonal together. Now, they always seem to wind up being on this one, but I could have stuck 1 and 6 over here too, all right, and put my 2s and 3s elsewhere. So, I mean, we had a lot of ways to do it right, but only one way to really mess it up here, and probably another way if you try to do 3 over 2 or 3 over 1 equals 2 over 6, you would have had some problems, all right? So, again, that is what we're looking for here, all right? So, again, lots of ways to do things right when you're doing proportions, as long as you do what? As you keep the pattern going. As long as you can cross multiply and get the same value on both sides. We call these two, the 1 and 6 in this case, we call these the extremes. 2 and 3 we call the means. And there's a nice little statement a lot of geometry books still use, called the product of the means equals the product of the extremes. They may even say the product of the extremes equals the product of the means. It's fine. That works both ways. But in other words, when you cross multiply, you're going to get a cross product that is the same going both ways, all right? Can't multiply across, can't multiply up and down, but you do on the diagonal. You what we call cross product, make that big X, that's why it's a cross, okay? And that's our story on that. Now, I want to remind you, lest I forget sometime during the show here today, we are showing all of our summer stuff and also all of our specialized segments. We are eventually going to have some fun with streaming them, and that means they're going to be on YouTube. So let's talk YouTube. How do you get there? If you have not subscribed to www.youtube.com/Mathline, we're going to try to add some material there every week for you to get to if you don't get to watch us every day on the show, which we hope you do. But you know, you can download us there. You can subscribe to that. You can watch us there. You can work the problems. You can stop, start as you wish, I would say. And you know, it's fun that way. Another thing we've got for you is still Facebook. We're going to be notifying you what's the topics that we're going to be covering from day to day, and maybe giving a few little problems along the way, maybe a problem of the day types feature or something this summer when we get in the mood to have some interaction from you guys, because we do miss you during the summer if we don't hear from you. So definitely like us, love us, share us, but by all means, watch us somewhere and hang out with us. We want you to be a part of our summer, all right? We want to be part of your summer again. No chances to do call-ins, but you do have that access to our email, and we'll be glad to address problems that you have, and we'll get back to you. And another thing we might do is even feature one of the problems on the show and just give you a little credit for sending us that, all right? So feel free to do that. We love it when you do that. Email is a great thing. Speaking of proportions, let's go through one more here, all right? We talked about cross-multiplying. Talk about all those little numbers. We use small numbers there. Let's use some numbers that aren't so small here. Jaquez is going to be downloading a 40-minute video on his computer. Now, I've talked to our technicians, and a lot of things really play into how long does it take to download a video onto your computer. Well, a lot of it depends on how the video is made. If it's poorly made, it's not going to take as long, I understand, because the pixels aren't not as good, and the good old refinement of the visuals that you see and all that, it's not as good. But if you're in high def, oh my goodness, it's going to take a little bit longer, all right? So maybe a lot longer. So we're going to kind of go for try a happy medium here. We're hoping he's got a good computer and he got a fairly decent quality video here, all right? But let's talk about Jaquez's story here. It takes 32 minutes to download a 40-minute video. So he's making good time. Hey, go do something else while you're doing the downloading part and trust your computer to take care of business. How long will it take to download? A 2-hour movie. All right, so we got a 40-minute video and we got a 2-hour movie. Now, what we want to do is let's have some ratios going here. All right, 32 minutes to 40 minutes. That's what I'm noticing. Okay, 32 minutes to 40 minutes. That's a ratio right there. That's important to us. Now, what is that? Everybody with me? This is download time versus length of video. So let's make that into a fraction because we're going to make a proportion here. 32, put it over the 40. All right, now we also would like to figure out a 2-hour movie. Now, that's because, notice that says 2 hour. That's not 2 minutes. That's how many minutes actually? How many minutes is a 2-hour movie? I'm going to give you 120 minutes. You're going to try to figure out how many minutes does it take to download. And that's if your rate keeps working, it should be in proportion. All right, you should have a constant rate going on here. So let's see. Remember over here, what did this stand for? Download versus actual length. Download time, well, we know it's going to take what? Don't know, do we? How long is the movie? We know that much. It's 120 minutes. 2-hour length movie. Not the Avengers, because Avengers was 3 hours, okay, if you're trying to do that. You can't download it yet anyway. It's going to be a while before you get to that one. Great movie, by the way, for those of you who have not seen it. Little plug there, cheap, shameless moment here, but it is a great, great, great experience for the summer. Now, let's go with it. Cross-multiplying here. 40x. Oh, we know what x is, but we're going to find out, right? On the other side, how about it? Let's take 32 times 120. And all of you are going like, ooh, Ernie, that's not a pretty answer, is it? Let's go to the calculator. I knew we'd get there sometime, right? So let's do it. 32 times, y'all been waiting. I'm glad I get to use my calculator finally. He told me to get them out. Yeah, here we go. Let's see what we have. We have 30, oh goodness, we got 40x equaling, it looks like 3840. Now keep in mind what we did. We just cross-multiplied. It's time to figure out what x is in this case. And by the way, in this case, x is our answer. We don't have to go back and multiply it by this or multiply it by that. This is the real deal. This is what we're looking for right there. So let's take our 3,840 and divide by 40. And let's see, hoping that that will come out beautifully. It should. Oh, it does. It does. So here we go. Everybody, drum roll. Drop my lower. Oh, they've dropped my lower third for me. They're great. 96 minutes. Now, what does that tell me? We think of 96 minutes. Now, how long is that really? We said 2 hours up here. That would be what? Hour and? You got it? How much? How much? Hour is 60. 36 left over, hour and 36 minutes, right? So again, we won't make it a colon here because that will look like, yeah, but it's 1 hour and 36 minutes. There you go. That's your length of time. So plan to do something while it's getting downloaded there, Jaquez. All right. Hey, folks, thank you for tuning in today. Hope you got a little bit of fun with it. We're going to be light and airy at times, and we're going to try to give you some real stuff, real world math here. And you know, it's summertime, relaxing, and we are going to be around. But remember, we gave you those alternatives between Facebook, between YouTube. You can keep up with us. You can also keep up with us just by watching, all right? And we're so glad you were here today. And again, make that note. It's always the same time. We're going to be doing here every weekday, same time, same place. You be here with us, and we will have a great time together, and we'll see you then.